Hello again. I'm Badr Benjloun. Glad for hosting you in this new webinar of the INRA Webinar series dedicated to discuss trends and innovations in agriculture. I would like to welcome all of the participants from different countries, maybe for taking the time to attend this webinar, and probably also to enrich this session by their questions and comments. Before we start, I want to ask all the participants via Zoom, please mention your full name and affiliations in your ID in this session. For people who are not familiar with Zoom, you can click on participants in the bottom of your Zoom window, then click on your name and select more, the option more, then rename. We will wait 5 minutes. My colleague will reject the participants who are not identified at all. Thanks for your understanding. So I will give directly the floor to my colleague, Mr. Mohamed Boughlala, the head of the Regional Center of Agricultural Research of INRA in Stat, who will welcome and introduce our guest speaker and also the topic of our webinar. Then I will talk about the schedule of our webinar later. The floor is yours, Si Mohammed.
Thank you, Badr. We are very pleased to have Mr. Barry Mudge with us in this webinar. And many thanks to Barry. He accepted to give this presentation and to share his experience in no-till farming in Australia with us. Barry Mudge is an agricultural economist. He's a scientist, and he has been directly involved in both practical and technical delivery to agriculture for over 40 years. He was employed for 20 years as a rural officer, in a regional manager in Commonwealth Development Bank. He then managed a family farming, so he's a farmer, family farming property in the upper north of South Australia for 15 years before becoming a part-time consultant with Rural Solution. Rural Solution is a company specialized in information and consultancy to enhance, mainly to enhance agricultural competitiveness and also improve environmental management, strengthen regional communities, and establish sustainable business practices. Barry commenced his own consultancy firm called Barry Mudge Consulting. He continues to manage the family property with the valuable assistance of his family. He brings a strong particular agricultural economics focuses to delivering outcomes at farmer level. He also has focused on understanding tactical and also strategic resilience in predominantly low rainfall farming system as our environment here in Morocco. He has also played a key role in identifying opportunities to improve water use efficiency and capacity building in low rainfall farming system across South Australia. Barry Mudge also have a good know Morocco and the environment in Morocco through his participation to CANA projects, which is a conservation agriculture for North Africa projects. The objective of this project was a rapid adoption of conservation agriculture. So the topic of today presentation is the Australian experience in no-till farming, and there is really a similarity between the South Australian environment and also Morocco, mainly arid and semi-arid region. So we are really happy and pleased to to have Barry Mudge today with us in this webinar and to hear from him. Thank you. The floor is you, Badr.
Thanks a lot, Si Mohammed, for this nice introduction that shows the large experience of our guest speaker. Thanks. Before giving the floor to you, Mr. Barry Mudge, I would like to mention that the main talk will take up to 30 minutes. Then my colleague, Oussama El Gharras, expert in no-till farming at INRA Stat, will give a summary of this talk in French. And this will take up to 5 minutes. Then we will have the Q&A session that will take up to 20 minutes. For the Q&A session, please post your written questions via the chat on Zoom. Please do not wait until the end of the conference to ask them. You can post your questions in English and in French as well. So we look forward to listening to you, Mr. Barry, and to knowing more about this exciting experience. The floor is yours, Mr. Barry.
Thank you, Badar, and welcome everybody. I assume I see that Morocco is, of course, in the middle of summer and going through some quite hot conditions. And I looked up the forecast today, and I see that that is around about 40 degrees in the next 3 or 4 days. So quite hot. Of course, we're in the middle of our winter, which is showing to be quite a dry winter, much very similar to what you had there last year, I believe. And I guess it just reflects, and as Mohammed just pointed out, the incredible amount of similarities there are between Morocco and Australia in terms of the farming system. I've been to Morocco a number of times, and I've always been struck by how similar our farming systems are because the climate is so similar. We both face similar challenges with variable rainfall. And I love Morocco. I think what you're doing there, the work that the researchers are doing there is wonderful in helping the farmers, I guess, counter the challenges of these sorts of environments. So at the outset, I will say that I am obviously presenting this in English. I would love to be presenting it in Arabic or French, but my skills do not go that far. So I hope you can understand me. I'm sure I have an Australian accent, but I will try to pronounce things as well as I can so that you can get the maximum out of it. And please, as Badar said, put things on the chat and we will go through those later on. And I also wish Oussama luck in translating what I'm going to say into French in 5 minutes. I reckon that is a huge challenge, but that's okay. We will progress. So the title is South Australian Experience in No-Till Farming. Now, I'm actually not going to talk a lot about no-till farming. I'll talk about the system that we use around no-till farming, but no-till farming itself is not talked about anymore in Australia because it has now become standard practice. Everybody uses no-till farming. So as I say, we don't talk about no-till anymore, we just do it basically. So I'm going to talk to a large extent around the system that goes around no-till farming and why no-till works so well in that system. So just a bit of a, first up, I'm going to do a geography lesson just to explain where we are. So this is a map of Australia. The Mediterranean climate is in the southern areas of Australia. I'm in the state of South Australia. I'm assuming you can see my cursor moving around on the screen. Is that right? Yes, hopefully. So if we go to the state of South Australia, this is the state of South Australia. You can imagine turning not sure why I've got that mark on there. Doesn't matter. You can imagine turning South Australia upside down and sitting it over the top of North Africa, and it would be a very similar climate system. Along the coastal areas here, we have a high rainfall, maybe 500 to 600 millimetres, which is high by South Australian standards. As we go further inland, it becomes drier, maybe 400 millimetres. We live here at a place called Port Germain, which is 250 kilometres north of the capital of Adelaide. We are back to about 300 to 350 millimetres. So that's not that different to that or that sort of region. Now, I thought I would just talk briefly about our farm, because I do regard myself as number one, I'm a farmer and I do other work on the side, but I'm a farmer. So I thought, I said before that there's great similarities between Morocco and South Australia in terms of the climate, in terms of the farming systems. There are some really significant differences, and it's mainly around scale. So I'll just run through a little bit of the stuff that we do on our farm, just to give a sense of what that scale is. Not that we're not a large farm, we're sort of just a medium-sized farm, I suppose. So we live on the farm. That's the house we live in. And this is my grandson in a crop of barley taken about 3 weeks ago. You can see the topography. It's fairly flat, but we have this range of hills in the background. But basically it's just reasonably flat, undulating coastal land. In terms of I'm not too sure. Can you turn on? Can you see that line across there? Is that showing up on on the presentation?
Yes, we are seeing.
I have no idea.
I don't know why.
Anyhow, it doesn't matter. You'll have to ignore that. I won't try to remove it. I've got no idea why that is there. Anyhow, it doesn't matter. Okay, so this is the growing season rainfall. So we have about 350 millimetres annual rainfall, about 220 millimetres on average in the growing season. And of course, our growing season runs from April to October, whereas yours, of course, is 6 months out, running November to, say, May. But you can see the main thing I just wanted to show here is just how variable the rainfall is. And that is very similar to your own situation. Sometimes it's very wet and sometimes it's very dry. So in a very dry year, we have around about 100 millimetres of rainfall. And on 100 millimetres of rainfall, we do not grow very much at all. On 300 millimetres of rainfall, we grow a lot. So that's what we have to learn to cope with. Just very briefly, in terms of the monthly rainfall, again, very similar to yours. There's a concentration during the winter and spring months, but a little bit different to Morocco. We still get some summer rainfall, and that's really important to our farming system because we're trying to capture that summer rainfall in any way we can to assist us in our productivity. And I'll talk a little bit more about that as we go along. So my farms, yeah, I've done that, Mediterranean climate. Our farm size is about 1,800 hectares, and we crop about 1,400 hectares each year. And like I say, that's not a large farm by Australian standards. In fact, it's probably on the small to medium size. And average crop yields are in the order of 2 tonne to the hectare. That's cereal yields. We grow a lot of lentils at around about 1.2 tonne to the hectare. Canola, perhaps around about 1 tonne to the hectare on average. So they're the sort of yields we're dealing with. And we also run some breeding ewes, some sheep, and produce meat lambs for sale. The really important thing is that possibly similar to Morocco, but certainly in our case, Australia produces more, it's quite different from Morocco. Australia produces more food, grain and livestock products than we can use in Australia. So we are, as a farmer, we're totally exposed to the world market. If we can't, we have to be able to produce the product cheaper than we can sell it for. Otherwise, we will go out of business. So we've had to develop a really efficient system to allow us to produce product at a very cheap price. And that is a highly mechanized, very low labor input system. So just as an indication of that, our 1,800 hectares and our 500 or 600 ewes is run basically with one labor unit. Between myself and my son, we both have external jobs, but roughly one labor unit. But of course, when we're busy, which is the sowing time and the harvest time, we will bring in extra labor. So we usually have 3 to 4 people when those busy times, say 2 to 3 weeks at sowing, and maybe 3 to 4 weeks at harvest, we'll bring in extra people to help. So, but basically, most of the time we run the farm with one labor amount. What else have we got here? We got livestock is very important in an annual cropping system, as it is in Morocco. Your livestock is very important to you. So integrating those two enterprises works well, but we'd have to work on that. And conservation farming is standard practice because it works. So that's always there. It's a heavy focus on improving water use efficiency. And I know it's again the same in Morocco, but we are in a permanently moisture constrained environment. We can't do anything about that, but we can do a lot about how we react to that. And so when we have a very dry year, we know we won't produce any crop, but when we have a good year or a wet year, we have to use that rainfall incredibly well to make sure that we can weather the storm when the poor years come. So that's the focus. Very heavy focus on improving water use efficiency and a high priority on managing the risk, the climate risk that goes with those bad years or those dry years. Okay, I thought I'd just very quickly go through the machinery that we use to be able to run a farm of this size with a very little labor units. The tractor is a 300 horsepower tractor. It's actually 25 years old, that tractor, so it's quite an old tractor, but it's fully set up with GPS, 2 centimetre accuracy, auto steer. The seeder is a John Deere Conserva Pack direct drill seeder, 12 metres wide, 8 tonnes seed and fertiliser capacity. We sow at 30 centimetre row spacing, and we use a 75 millimetre paired row. So we're actually spreading the grain across 75 millimetres and then sowing every 30 centimetres. So you can see here's a couple of crops. So we like to inter-row sow. So in this case, this is lentils that have been sown back into last year's wheat stubble. So with GPS technology, we can do that. And the ideal situation here is that the wheat stubble acts almost as a trellis for the lentils to climb up, hold them up further in the air so that for harvesting purposes, it's a lot easier. And you can see here, this is a wheat crop, again, sown at 30 centimetre row spacing. So by the time it reaches tillering or advanced tillering, we've got full coverage. So the 30 centimetre row spacing doesn't worry us because we still get full coverage. Of course, spraying. We do lots and lots of spraying. I will allude to that a little bit later on. And most people now run quite large self-propelled boom sprays. So this is the unit we use. It's 36 metres wide, 5,600 litres. We would probably go over our country perhaps six to 7 times a year. So if we're sowing 1,400 hectares, we're covering perhaps 10,000 hectares with that unit. So it has to be reasonably efficient, and it is. And harvesting is just an American harvesters. Again, a 12-meter capacity, 12-meter wide front, harvesting approximately 30 tonne an hour. We would expect on a good harvesting day in good crops to be reaping perhaps around about 250 tonne a day is about what we aim for. And just on that, that's the same harvester putting into lentils. So all the lentils are direct headed. That's a fully flexing comb or head so that it can follow the contours of the ground. And that bar on the front, that silver thing on the front, is actually an air manifold. There's a fan up here, and that blows a jet of air onto the cutter bar to improve the flow of the lentils onto the mat that pulls them into the harvester. And we think we'd probably save 1 to 2 quintals per hectare by improving the capacity of the machine. So that's the technology we use for harvesting lentils. And we can harvest. Last year, for example, in quite a poor crop, we were harvesting about a 6 to 8 quintal crop, and we did about 120 hectares in one day with that machine. So we can harvest very quickly at large areas. Conservation agriculture. Again, if we talk to Australian farmers and ask them, are they practicing conservation agricultural principles, they'd probably look at us somewhat strangely, but everybody does it. We don't call it conservation agriculture necessarily in this country. We just call it good agronomy or good agriculture. The principles: minimum soil disturbance, no-till, permanent soil cover, species diversification. So I'll just run through those and what we're doing in that regard. First of all, why no-till? Well, we all know this, so I'm not going to spend much time on this. We know that no-till reduces soil erosion risk. So when I was growing up, this was common. Wind erosion, very common. Water erosion, again. So no-till was encouraged initially to start stopping some of those problems, and it did, because we're keeping cover on the ground, we're not cultivating. But we actually found that it had so many other advantages as well. So there was much greater flexibility for our farm operations. We weren't spending anywhere near the same amount of time in the paddock, so we could actually handle more. Each person could handle a lot more than they would otherwise. Much more accurate seed and fertilizer placement, resulting in better yields, greater use of moisture, less cost, and a side benefit was that a lot more options with weed control, particularly with herbicide use. So again, they've been well documented. I don't want to spend time talking about those, but for all those reasons, the system worked well. So everybody went no-till. Possibly happened. We started no-tilling in 1990 using various equipment, and we've gradually changed and evolved. So we've been doing it for 30 years. So we haven't cultivated our land probably for 20 to 25 years. But and we wouldn't do anything else. So stubble retention or getting cover, and that's about in part it's about erosion, but it's also about conserving moisture. So here's a photograph that was taken. So we can see the much better crop that's growing here, and that's growing in the tailings out the back of a harvester from the previous year. So it's just a reflection of the fact that this would have had stubble on it or residue on it, whereas alongside has no residue. So it just reflects how important stubble cover or residue, we call it stubble, but residue, how important residue is for improving water use efficiency. And the other thing is around rotations and crop diversity. We don't actually talk a lot about rotations as such. We'd prefer to use the word crop sequencing. So we we're trying to work a system where one crop does the maximum benefit for the next crop, which is a rotation, obviously. And on our farm this year, to give an indication of what we're growing, we've got about 500 hectares of bread wheat, 200 hectares of barley. So a quick sum, 700 hectares. So roughly half the cultivated land is planted to a cereal. And that would be roughly about the right amount, roughly half a cereal. And in addition to that, there's 550 hectares of lentils and 200 hectares of vetch pasture. So that's sown. It's sown at the break of the season, as we would normally sow. After a month or so, our sheep are turned on that. So the sheep go on that in our case, they go on that when they're lambing, and they'll grow their lambs on that for a while. And as soon as the vetch gets, so there's nothing else growing with the vetch. There might be some weeds, but there's no cereal or anything like that with the vetch. As soon as it starts to flower, or certainly before it starts to set pods, it is just eliminated with it's just chemically fallowed. We call it brown manuring. And what that does, it does about three fantastic things for water use efficiency. Number one, it retains some moisture in the ground because it hasn't grown to full maturity. There's still moisture left behind in the ground. It's produced a lot of nitrogen, so that's really good for the following cereal that's going to come along. And the other thing it's done is it's completely eliminated any weed seed set. So the vetch has been killed, so that hasn't set seed at all, and any weed in that field has been eliminated. It won't seed. So as we say, 1 year's seeds is 9 years weeds. So it's just a system where we rotate this around the farm to give a complete break for weeds every so often, every few years. And it works extremely well. We always grow our best crops after that vetch pasture. We have grown canola, beans and peas. We haven't, the best, yeah. So I'll go to a summary slide of our rotation. So cereals are probably the main thing we grow because they work in lower rainfall environments. Oat and hay, we actually export oat and hay to China and Japan in very heavy bales. So that's a good fit. The profitable grape crop, I hope you know what I mean by a break crop, breaking from cereals. We call them break crops, pulses, lentils, canola, whatever. A profitable break crop remains the absolute key to a sustainable and profitable rotation. So we do an enormous amount of work getting the break crops, the alternative to cereals, right, so that we can make money out of them. Incredibly important. And sometimes that break crop is the vetch, and we're just grazing sheep on it, which is fine. That works too. Lentils are our main one. Canola has potential, but what we find with canola is you've just got to use the absolute best agronomy, as we always have to anyhow. But canola in our situation has to go back on paddocks with high levels of nitrogen. So it has to go back on a legume pasture or a legume. And it also has to it has to be sown early, and we have to use the right varieties. So it's just got to fit in the right part of the rotation, and we can usually grow a reasonable canola crop if it rains enough. And livestock have a strong role as well. I'm just going to talk a little bit about water use efficiency, and I'd say the reason why we practice conservation agriculture and no-till and all these things is it's all about trying to grow the maximum amount of grain for the rain that falls. And so what have been the drivers increasing wheat yields in South Australia? Well, one is improved genotypes. We've done a fantastic amount of work in breeding, and right across the board, from cereals to the pulses to canola, we're very fortunate to have much better varieties than I had, certainly when I was growing up 30 years ago, 40 years ago. We've got much better varieties. So that's great. We reckon roughly a third of our gains has come from varieties. Fertiliser, I won't talk about that. We know how important fertiliser levels are and we're doing that a lot better than we were. Improve rotations, I've talked about that. Certainly our rotations, the amount of break crops that we're growing now is much higher than it was. Many more legumes in the system than we had. And that's proven itself to be very good in terms of growing more wheat. We know how important a break crop is. So we're growing more and more break crops. And as we've learned to become profitable with those break crops, that's been helping. Mechanisation, really, really important. For example, now, and I know you do this as well in Morocco, but we now have moved to calendar seeding. So basically, when we get to a certain date in the calendar, whether it's rained or not, we will go sowing. It's about the 15th of April in our environment. And to do that, you need pretty good equipment because the ground's always hard. So mechanisation has allowed us to do that, along with a whole heap of other stuff as well that we've done to allow us to seed dry and still grow successful crops. And that's all about, seeding dry is all about just early crop establishment. So that's one of the most important drivers of water use efficiency, certainly in our environment, is early crop establishment. Conservation tillage systems, and that in part allows that early crop establishment. Improved weed control and improved out-of-season moisture. And I want to just finish up because I'm looking at my time and I don't want to go over, otherwise Osama will tell me off. I just want to just briefly go on to a little bit about weed control because it's probably the major challenge that we have in our system. We have what I call a fastidious approach to weed management. It's a take no prisoners attitude. Whenever we can kill a weed, we do. So, and we have a very good array of herbicides available to us with a whole range of different mode of actions. The use of herbicides is heavily regulated in Australia, but we still have a wide range available to us. We note, for example, the ongoing debate about glyphosate. Glyphosate is probably the most widely used chemical in Australia. We don't know where we would be without it. And we have no worries at all about using glyphosate. It's just, so we use it very heavily. We would use approximately 3,000 to 4,000 litres a year on this farm. And without it, we would be far less productive, and we certainly wouldn't have the. We believe it is a sustainable use. Other people may have different ideas, but we believe it's a sustainable use. But what's happened, of course, is the heavy reliance on chemical herbicides has resulted in weed resistance, and it's widespread. Varies between different chemicals, different weeds, whatever, but a lot of weed resistance. So the new doctrine is, if you're on a good thing, don't stick to it. So we've got what we call the Smart 6, and it's just 6 different mechanical, cultural, chemical tactics that we use to, if you like, don't give the weeds an even break. So we rotate crops and pastures so that it allows us to expose them to different types of weed control. As simple as a sheep grazing a pasture will have some level of weed control. We double knock to preserve glyphosate. So glyphosate being a knockdown chemical, we'll use another knockdown chemical in conjunction with glyphosate to make sure that glyphosate is maintained in its effectiveness. We mix and rotate herbicides using different groups, and I assume you're aware of the different groups, herbicide mode of action groups. And we every time we buy a drum of chemical, the mode of action is set down. So we try to have at least 2 modes of action operating in any one application. Stopping weed seed set is a really important thing of what we do. Increase crop competition by either narrow race spacing, more competitive crops, or just higher seeding rates. And the other thing that we're doing now is a lot of implementing harvest weed seed control. And so many of the harvesters we have now have what's called a seed terminator fitting on them. So they collect the chaff portion of the harvester, which is where all the weeds are, and they just pulverize them and push them out the back as dust, and so kill the weed seeds that way. So there's many things happening there. And the other thing I just mentioned there was about some fallow weeds. One of the biggest changes in recent times in our farming system has been just the elimination, what we'd call zero tolerance of any summer weeds growing. So by summer weeds, I'm talking anything out of season. For example, here's an example of it. On the left, we have just towards the end of summer, a splattering of weeds that have been growing there over the summer. On the right, they've been eliminated. And we've measured the difference there. It's about 30 millimeters less soil water at the start of the seeding program, sowing program on the left than there is on the right. And that'll equate to a yield potential of about 0.7 tonne per hectare. So we reckon we get around about $5 back for every dollar we spend on summer weed control. So it's one of the main changes in the last 20 years, other than the no-till and whatever, but it's summer weed control is enormously important. And I recognise, of course, that in Morocco, you don't get a lot of summer rain, but at the same time, as an example, this year, we didn't get any summer rain either, but we had 100 millimetres of rainfall at harvest last year. Very little rain after that in summer, but at harvest, 100 millimetres. And we fastidiously controlled summer weeds all year. And we ended up, again, I can measure that moisture in the soil. I measured 40 millimetres. We'd conserved 40 millimetres of that 100 millimetres that fell at harvest last year. That 40 millimetres is what we call gold. It's just, it almost guarantees that we will grow a crop this year. So it's enormously important. All right, now I'm looking at my time and I think I'm just about 30 minutes up. I can keep talking for the next 2 days, but I won't. I'll just very quickly mention this. This is just some really interesting technology that we're now using reasonably often. So this is a spot sprayer, an optical spot sprayer. There's a camera mounted on the front there, and it senses a weed using infrared, I think, senses a weed and then turns the jet on as it goes over the top. So we can be still spraying at 15 kilometres an hour and it will still pick it up and turn the jet on early enough. So we end up spraying perhaps 10% of the paddock when there's scattered weeds. So it enables us to target difficult to kill weeds, particularly in summer. This is all about green on brown. We can't use this. We haven't got the technology to use this in crop yet. It will come, but this is for summer fallow control of weeds. So that's allowing us to use much lower levels of chemical. All right. I think I'm going to pull it up there and perhaps ask Osama, you're going to do a summary of that, are you?
Yeah, I'll try to. Yes.
Good luck.
Go ahead. Bye. Then, thank you very much, Barry. I'll switch to the other language that you understand very much. Donc, je pense que la présentation de Barry Mudge a été très, très riche. Donc, en réalité, c'est un peu difficile de pouvoir résumer tout ce qu'il a reporté, mais je vais essayer de mettre l'accent sur les choses les plus importantes. Donc, il a commencé par présenter l'Australie. Et donc, l'Australie du Sud, d'où il est, Donc, c'est presque prendre le Maroc à l'envers, c'est-à-dire faire la rotation de 180 degrés. Donc, les régions les plus humides sont au sud de l'Australie du Sud, les régions les plus arides sont au nord, donc ce qui est opposé pour nous au Maroc. Donc, pour l'exploitation, il exploite 1800 hectares dans sa ferme, donc, dont 1400 en général et en culture. Donc, les autres 400 en général sont pour.
Hello, Osama. We've lost you, maybe.
Donc, je m'excuse, je ne sais pas pourquoi le micro a été.
On vous appelle.
Donc, je vais revenir, c'est-à-dire Barry Mudge est de l'Australie du Sud. Donc, et comme j'ai dit, l'Australie du Sud est complètement opposée, c'est-à-dire plus vous allez au nord, plus l'aridité est accentuée. Donc, c'est comme si vous tournez le Maroc à 180 degrés. Donc, le sud de l'Australie du Sud est plus humide que le nord. Lui, il est dans une région limite de culture qui reçoit presque 200-250 mm, 300 mm. Donc, les données climatiques qu'il a présentées, comme vous l'avez pu voir sur le graphe, à partir de 1900, ils ont toutes les données climatiques à la disponibilité des agriculteurs dans la version qu'ils veulent jusqu'à la campagne, c'est-à-dire l'ISM. Donc, la grande différence entre le Maroc et l'Australie du Sud, c'est que eux, ils reçoivent une pluviométrie sur les 12 mois de l'année. Donc, même pendant les périodes d'été, qui sont en réalité notre hiver, décembre, janvier, février, ils peuvent recevoir de 15 jusqu'à 30-50 mm de pluie en été, ce qui crée un challenge, c'est-à-dire une contrainte sur laquelle nous allons passer. Donc, les rendements moyens pour les céréales en général sont de 20 quintaux par hectare et il a une production animale très importante de brebis et il produit des lentilles, des petits pois et de la veste. Donc, sur l'exploitation, ils ont une personne en permanence, c'est-à-dire qui travaille, et 3 à 4 personnes pendant les périodes de demande, c'est-à-dire pendant les périodes de semis et de récolte. La production animale est très importante et le grand challenge, c'est-à-dire le grand défi qu'il rencontre, c'est le même, c'est l'efficience dans l'utilisation de l'eau. Donc, son parc agricole est constitué d'un tracteur de 350 chevaux, un semoir de 12 mètres, un pulvérisateur de 36 mètres et une moissonneuse-batteuse de 12 mètres. Donc, comme vous pouvez le voir, tout est multiple de 12. C'est-à-dire les engins qu'il utilise pour avoir toujours les mêmes passages et les mêmes smitos pour ce qu'on appelle l'agriculture de précision. Donc, les lentilles sont semées entre les rangées des céréales. Donc, ce qui permet en réalité aux résidus de céréales de supporter la lentille et de la laisser standing, c'est-à-dire érigée. Donc, ce qui va faciliter la récolte par la suite. Donc, les superficies sont de 500 hectares pour les blés, 200 hectares de l'orge, 550 hectares de lentilles et 200 hectares pour la veste, pour le pâturage des brebis. Donc, une fois la formation des gousses, donc il y a traitement par glyphosate de cette veste pour pouvoir garder l'eau, pour pouvoir éliminer toutes les adventices, toutes les mauvaises herbes qui vont pousser et principalement pour l'azote, pour séquestrer l'azote en réalité qui, au lieu de le transférer dans le grain ou bien la formation de gousse, de grain, c'est de l'azote qui va être utilisé par la céréale qui va suivre. Donc, la culture de colza est très importante dans la rotation, ce qu'ils appellent les séquences de culture. Mais comme il a dit, c'est-à-dire si vous réussir une culture, il vaut mieux l'abandonner que de se casser la tête à faire des erreurs et à ne pas réussir les choses les plus importantes, comme j'ai dit. Le grand challenge qu'ils ont, défi qu'ils ont, c'est qu'ils peuvent utiliser le glyphosate de 5 jusqu'à 7 fois pendant la campagne et principalement pendant l'été. Donc, je vais dire, c'est-à-dire comme il me l'avait dit, si vous voyez une mauvaise herbe, c'est-à-dire une adventice indésirable sur un champ, il faut la tuer, il faut l'éliminer et ne pas laisser cette mauvaise herbe consommer l'eau et infester le champ parce qu'elle va mettre des semences. Donc, le challenge nous pousse à dire que ils sont maintenant vers la limite des technologies où ils utilisent un pulvérisateur avec une caméra et donc le produit n'est pulvérisé que sur la plante, ce qui permet en réalité d'économiser presque 90% du produit. Au lieu de pulvériser sur la totalité du champ, donc il ne pulvérise que les plantes indésirables qui sont sur les champs. Donc cette technologie est utilisée aujourd'hui beaucoup sur les chaumes, c'est-à-dire pendant l'été, comme j'ai dit, mais encore sur les cultures, elle n'est pas encore très pratiquée. Mais le plus important, c'est que dans la gestion des adventices, il parle d'une rotation pour pouvoir réduire le stock semencier dans le sol, ce qui est très important, et le choix des cultures qu'on réussit. Et il ne faut jamais, comme il l'a bien spécifié au départ, il ne faut jamais s'entêter à pratiquer des cultures qu'on n'arrive pas à réussir et qui ne sont pas économiquement rentables. Donc, je pense que c'est un résumé de l'intervention et je reste à la disposition par les collègues qui peuvent.
Merci, Si Osama. Thank you, Mr. Barry, and also Osama, Mr. Barry for the rich presentation, and Mr. Osama for the very relevant summary that you have made. So good. Now we are going to have the Q&A session. We have many questions on the chat. You can see them, Mr. Barry, and we have also maybe people that would like to ask their question and to say their comments orally. It is possible. If you would like to do this, please raise your electronic hand. So we'll start with the question on the chat.
Right.
Yes, the question of Ali Amamu is from your big experience, are there any wheat or food legumes cultivars adapted to no-till system than others? If yes, what are their main characteristics? Deeper roots, for example, or early flowering, and so on. The floor is yours, Mr. Barry.
Yeah, no, I think the simple answer is that there isn't, because the no-till system essentially is just a different way of establishing the crop rather than cultivation. So a cultivar that works well in any situation will work whether it's tilled or no tilled. Now that's a different question, of course, is how does climate, in particular climate change, what's the influences there that may be changing our need for adaptive cultivars? That's a different question again, but I think the actual mere fact of establishing a crop with no-till or cultivation doesn't change things. But yes, there is certainly a need to continue to adapt cultivars to a changing climate. So that would be my answer to that one. Do you want me just go straight on to these next questions, or do you want to highlight?
Yes, I will say that about it because there are many questions from Omar Idrisi. 3 questions actually. The first one is the harvester machine you are using for lentils, specifically designed and manufactured for lentils and other crops having lodging problems, or was it adapted locally at farm level to be adapted to lentils, for example?
Yeah, no, the bar that the cutter bar, or the head, or whatever you want to call it, the comb, we call it a comb, but the head is actually a Canadian design. It's a MacDon. You buy them off the shelf. They are set up for flexing to flexing across the contours of the land, but it's a standard off the shelf comb, and we use that comb across all our crops. It's an expensive piece of equipment, but it's incredibly flexible, and I think most people would regard it as state of the art. And the air bar that we put on it is again an off the shelf item, and it's put there specifically 2 reasons: to help with lodged lentil crops, or help with lentil crops generally, but it also actually helps when we've got very low and poor cereal crops. They might only be perhaps 30 centimeters high, and we struggled to keep them on the cutter bar, and that blast of air just forces them onto the cutter bar much better. So it's just but it's an off-the-shelf item. There's no local manufacturer about that. It all was imported into Australia.
Perfect. The 2 further questions are actually associated, linked, because there is a difference between the situation in southern Australia and Morocco, and you know the situation in Morocco. What about water conservation and saving soils under no-till between both situations in Australia and in Morocco? And what is your recommendation for sustainable farming under no-till in Morocco? What is the best rotations?
I think that's a huge question, and I will struggle to do it justice. And I do note that right now in Australia, we're about to launch into a new 5-year program funded by our Grains Research and Development Corporation, trying to answer the same question in our environment. So it's not a simple question. It's not a simple answer. Your comment about, I'm assuming the inference in this is that you don't get summer and autumn rain in Morocco. So there's no point in trying to control summer weeds. My problem with that is that I've been in Morocco at the end of summer, and I've seen all the same weeds that we see, that we call summer weeds. I've seen them on your landscape. Now, we know they're doing 2 things. They're taking moisture and they're taking nutrients. Now, I know maybe it's not as severe as the situation in Australia, but a lot of the moisture we're trying to preserve is actually leftover moisture from the previous cropping year. So it's not just about summer rain. We quite often will get no summer rain, and yet we still have to control weeds in the landscape. So I actually did when I was in Morocco a few years ago, I did an APSIM modeling of this. And I certainly found it wasn't anywhere near as useful as it was in the Australian situation, but it still showed that when you had weeds, summer growing weeds, the best thing you can do is to get rid of them. So I'll leave that one there.
Thank you. The next question from Mohammed Mdawar from the World Bank. He's asking about the key messages for small farmers to adopt no-till farming. How to compensate residues for livestock with no-till in an integrated system?
Yeah, now it's another really good question. And it's about, I guess, trying to understand the profitabilities of all the different parts of the system. Now, you're absolutely. The fact is that small landowners need all those residues to feed their livestock. I guess the only so what we will typically do here in Australia is that we will dedicate some area of our farm for livestock production during the winter months, and we look to get maximum biomass production from those. As I said before, we try not to grow things that are deleteriously like weeds. We try to grow something useful, but we try to maximize the productivity of those areas so that the rest of the farm doesn't get impacted by the livestock. So that's the approach we use, but I recognise that the constraints that are in the Moroccan situation of small landowners are severe. And all you can do, I think, is just have the maximum productivity. Growers, so small areas of the farm, maximum productivity, and then provide those that provides the livestock. There's the thing with livestock is, and it certainly applies in Morocco, it applies anywhere you run livestock in an integrated cropping situation. You can run a small level of livestock and they are incredibly complementary with a cropping program. As soon as you increase the level to a certain stage, they become antagonistic to the cropping program. Now, you've just got to work out where that interface is. But and in our case, we quite often will run livestock at quite a low level because we don't want to reach that time where they become antagonistic to our crop program. Certainly on our farm, we regard cropping as much more important than livestock. Livestock is still important, but we try to maximise the return from our cropping. And again, we're trying to make sure that the livestock are complementary, not antagonistic. And certainly when you get the numbers up too high, they become antagonistic.
Okay. Thank you. The next question from my colleague, Mr Rashid, our expert in no-till farming also. He's asking about more details when Australia started adopting the system. Is there any subsidy from the government?
Yeah. And yeah, hello, Rashid. No. There certainly was never any subsidy from the government to support conservation agriculture. It started, it was probably about in the perhaps 1980s when a few people started experimenting with the ability to grow crops without cultivation, and of course with all the attendant benefits of that, with stubble retention, easier sowing, whatever. And it probably coincided with the use of tungsten as an addendum to the ground tillage implement. And I know there's a story told of one of the instigators, one of the pioneers of no-till farming, who just happened to be somewhere talking to an engineer, and how he said how he couldn't keep the ground engaging points lasting longer. And this engineer said, well, look, I know how to apply tungsten to a point and it'll last forever. And that was the starting point. So suddenly we could actually sow into a very harsh country and not use the points up. The tungsten was protecting them. And it just went and everybody started experimenting. We started experimenting. I remember having an argument with my father. I said, I'm going to go direct drilling. And he said, it won't work. We've been ploughing this field for the last 100 years. It won't work. So that was the challenge. So I went and modified a machine, took it out in the paddock, sowed the crop, and it worked. And so we just bits and pieces, we started adopting and changing machines, whatever, and the process worked, and all those additional things, the system benefits just dropped out of that. but we'd spend this is our probably fourth, the unit we're using now is our fourth iteration of a direct seeding machine. We just kept on modifying, changing. Eventually, this was the first machine we actually bought off the shelf. All the other machines had been home built, just changing things around so that all we needed was a high breakout time. Osama knows all about this, a high breakout time. And then you just sit there with a welder and an angle grinder and work a few things out. So no, we started roughly about the 1980s, and it was just self-fulfilling. It worked, so people kept on doing it to the stage now where everybody does it. And no support from the government. We don't get support from the government for agriculture in Australia.
Okay. The next question from Mr. Farisi from the Moroccan Agency for Agricultural Development. He's asking, how do you use cover crops to convert for the conversion to no-till system? What are the best cover crops to use in a no-till system?
I assume from the question we're talking multi-species cover crops. I'm assuming, which is something we're actually still.
Mr. Farisi, are you talking about the machines or about the crops? Okay.
Okay.
Let's go to the if you can precise, please, Mr. Farisi. Okay, waiting from his comment, we go to the next question.
He just wrote something on the chat that he's talking about the crops.
The crops, okay.
Okay. About the crops, okay. Yeah, all right, that's fine. Yeah, look, we don't use multi-species cover crops. But we would regard our vetch as a very looking at doing a similar thing. We have quite a large project happening at the moment where we are looking at multi-species cover crops to see whether or not that type of system has advantages, and I think we just need to wait on the results of that. I really can't comment on the best species. Again, we've got a major project happening at the moment, and the results will come out on that. But again, I haven't got any inside information on it.
Okay, thank you. The next question from Silami Wafa, PhD student at INRA Webinaire. Her question is about fertilization management in no-till system.
Yep. Yes, well, again, I come back to the same thing as I said before, that no-till is just a way of establishing crops. So the fertilizer management, we find it isn't necessarily changed by no-till. But I would say that fertilizer management has progressed quite substantially in the last 20 to 30 years anyhow, which again, essentially when we've all been no-till anyhow. So what we're doing, we're in an Australian situation, we've got quite old, poorly fertile soils. They're always deficient in phosphorus. So we love Morocco to send your phosphorus fertilizers to us. And of course, nitrogen is the other big critical element. And we've done an enormous amount of work in that regard. It still is a huge issue amongst farmers as to how to set their fertilizer management up in the face of a highly variable climate and a highly unknown climate. We don't know where the crop is going to end up at the end of the year. So it's a huge issue. We're doing a lot of work, again, in that area, trying to understand how fertilizer management impacts or interfaces with climate risk management. And so again, I'm doing a lot of work locally with a climate scientist in that regard, trying to understand how we might make better decisions around application of particularly nitrogen fertilizer in an unreliable or unknown rainfall situation. But yeah, in the context of climate change, yes, go on.
So the next question is from Satya Leila from INRA Stats. What are the IPM methods used to protect wheat fields?
Okay, we're talking about insect and disease management. Yes, so IPM. Well, I guess we use those systems. So the first defense always is hopefully some variety protection, varietal resistance, and then we have a strategy of benchmarking insect levels, the predator, the beneficials in a field, with the idea of not using harmful insecticides where we don't have to. Disease management. There's certainly we would try to have a canopy that doesn't allow the disease to express itself any more than it has to. So in higher rainfall situations, much higher rainfall areas, they will deliberately try to hold that canopy back, perhaps with the use of growth promotants. In our environment, a low rainfall environment, we generally equate big canopies with higher yields. So we're not trying to do that. In fact, we've got a really interesting discussion happening at the moment about use of very high canopy levels in lentils. So very early seeding of lentils, and I'm talking, in our case, sowing as early as March. So that would be equivalent to an October sowing, if the opportunity presents itself, which it doesn't very often. But the canopies that grow then by the middle of winter, we've got an enormous canopy, and that potentially opens up the spectre of disease, the molds, ascochyta. And so that's an interesting challenge. And again, I hate to say this, but we're just in the process of doing a lot more work in that area. But I get, once again, so this is, and I come back to the same theme a bit, that no-till isn't the question here. It is just a system of establishing the crop. It's the whole conservation agriculture has been a much more productive system, and so whether it's fertilizer management or any other management, a much more productive system demands a change in the cultural practices to allow for that extra productivity.
Mm-hmm. So the questions from my colleagues Barry and Barry and Farahi from INRA Morocco about glyphosate residues from Barry and also from Farahi, because glyphosate right now is taken out from the market, is being taken out from the market. What will be the substitute?
Right.
In your opinion.
Okay. Can I ask, what is the situation with glyphosate in Morocco? What is the current policy?
It's not brought out, but we are talking about it. So we can use it. It's allowed to use it.
Right. And well, I then would ask the question, why would it be taken out? What would be, is it health concerns or is it environmental concerns that would take glyphosate out of the system?
I'm not an expert, but maybe my colleagues will say, I think it's about health concerns.
Right. Okay. Yeah. Okay. Well, I'm not going to go into that other than
or both, because also there is
right.
environmental issues.
We'll talk about glyphosate residues. Yes. So we would be applying in our summer spraying program. Sometimes we would be applying, perhaps having 3 applications of up to 2 litres per hectare. So we might be applying 5 to 6 litres per hectare of glyphosate. Now we don't see, I've never seen any residue issues, and we can usually pick those up because there'll be areas around obstacles where the sprayer goes slower, so you'll have extra application in those areas. So we look for them all the time. We can measure, we don't do it, but there has been measurements taken, and they often will find the product, which is the breakdown of glyphosate to another product. They find that breakdown product in the soil. But essentially, we at the levels we use, even though they seem to be quite high, we're not finding any significant residue issues with glyphosate. There are many other chemicals that we use that potentially have a soil carryover situation, and we know about those. And so in some situations we have quite long plant back periods. We're not allowed we can't use a certain crop, say within 2 years of using a certain other chemical. But in terms of glyphosate, there is not a widespread issue at all with the soil residues, and so it remains an extremely popular, well used, and extremely useful chemical to us.
Okay, so I will go back to the question from my colleague Hilali from INRA. Her question about the herd size in your farm.
Herd size.
Herd size, yes. Herd
right.
size. Of the yes.
Right.
The 20 hectares of which are sufficient for the livestock that you have in your farm?
Well, that wasn't 20 hectares, it was 200 hectares.
200?
Maybe,
yeah.
200 hectares. So yes, we have 200 hectares of vetch, and that will be sufficient. We also have a level of grazing land, of rangelands that isn't suitable for cropping, so we also run livestock through there. But the 200 hectares of vetch is, yes, it's sufficient for our herd during those winter months when the vetch is growing.
What is the herd size? How many animals do you have?
I said on my presentation 500 to 600. We're actually a little lower than that at the moment. We're about 450 ewes, which are lambing at the moment. We would expect to mark about 550 lambs, so around about 120% will get lambing percentage. So for a while we will run 550 lambs with 400 ewes, and then the lambs will be sold off later in the year, and the ewes will be retained and remated. So it's a very simple livestock system. But yeah, around about, so at the moment there's probably close to 1,000 sheep on the 200 hectares of vetch. But the lambs are quite young at the moment, and they'll move on in due course, as most lambs do, to the great part in the sky that they go to.
So we've exceeded the time dedicated to the discussion, but we'll take 3 more questions because there are many questions in the chat. So the question from Adnan Beni Aish from the University UM60. His question about, do you think that only no-till system is enough to stop soil erosion? What about the management of soil organic matter in no-till in Australia? Can you talk a little about that?
Well, in terms of the soil erosion, all we can say is that it is far, far better than it was before no-till came in. So I won't say we never get erosion now, but it is a rare event, whereas 30 years ago, it was a very common event. So there's no doubt that the no-till system has reduced soil erosion substantially. And I'm talking both wind and water erosion. In terms of soil organic matter in no-till in Australia, the expectation is that no-till will improve soil organic matter levels. The reality is that in certain soil types, and certainly in the soil types that we're using, which are a sandy loam, it's very hard to increase soil organic matter. It cycles. Basically, we produce lots of organic matter to send back into the soil, but most of that cycles, comes back out again, and the actual stable soil organic matter, which is what we should be measuring, is very hard to increase in those soil types. Now, some soil types, particularly heavier soil types, and particularly those in higher rainfall districts with much higher levels of organic matter being returned to the soils, yes, you can get significant build-up of soil organic matter. So it really depends on where you are farming as to whether the no-till system is particularly beneficial. In our situation, it's beneficial for a whole range of reasons, but our soil organic matter hasn't moved for 30 years. It's probably stopped going down, if anything, but it hasn't gone up.
Mm-hmm. From Bendidi Abdelrazak, the question is, how do you manage nitrogen fertilization for wheat in the case of no tillage system?
Okay, well, I'll tell you about what we do. We have a policy when we're sowing. So you've got to remember, so my rotation said that I'm trying to grow around about half of our land to legumes, and that's mainly pulses to lentils or perhaps peas and some veg. So most of the time our cereals are coming back on top of a legume pasture or a legume of some sort. So obviously that provides us with a very good starting base of nitrogen. And probably about half of the times, so half of the cereals, we still have to supplement nitrogen. Now, just for logistics reasons, we don't do that at seeding. We will use diammonium phosphate, so it has some nitrogen, but the main thing we want to get at seeding time, we don't want to be handling large product levels, so we just sow the crop, and then we'll come back at the first opportunity and we top dress, and we use urea, so 46% N, granular urea as our main additive, and we just broadcast that, hopefully in front of a rain front, which then washes the urea into the soil. Now, the challenge there, of course, is actually working out what rate we're going to apply, and that is a huge issue. And again, if I had 2 days, I'd go through some of our working on how we go about doing that. But essentially, the rationale is we work on a target yield. We measure how much nitrogen is in the soil before we start sowing. So we know that. We know what we've applied. We know how much the target yield, how much nitrogen we'll need, which essentially is just the amount in the soil before we started and how much we need to add to get to our target yield. So that's the simple way that we do it. It can get a little bit more complex than that, but essentially we try to measure how much nitrogen is in the soil prior to sowing, and then work on a target yield, and we sort of know how much we then need to apply.
Okay, the last question so I will talk about 2 questions actually, but I will try to summarize them. The first one from Hajjaj Bad. Hajjaj Badr from INRA Tangier. Do you have in your farm resistant weed to herbicides? And what kind of, so absence on glyphosate? And also, do you have Bermuda grass in summer?
I'm not.
This is associated to the question of Harish El Hussein from INRA Stat about what are the challenges of no-till weed management in Australia. So it's actually they are associated, those questions.
Yeah. So yes, we certainly do have resistance. Most of the I'm going to say most of the resistance occurs with our grass species. You talk about Bermuda grass. I am not familiar with Bermuda grass, but sometimes, of course, these things have different names in different countries. We certainly do have summer grasses, and they become somewhat problematic. But we find ways of controlling them, sometimes by using that other machine, that optical sprayer, that helps. In terms of weed management in no-till, again, I did cover that a bit in the presentation, but it's very much about using every tool available to us. So I would encourage anyone interested in this just to Google Weed Smart Big 6, and you'll get a lot more information about some of the practices we implement to make sure we're not relying on herbicides alone. So I think that's a simple answer there. It's an enormous issue. We work very hard at it to I guess stop weeds being a problem for our water use efficiency. So we know we can't grow a crop of wheat if it's full of weeds. And pulses in particular, our legumes in particular, weed control is quite problematic. And so we need to use every tool in our arsenal to make sure that when our crops are being planted, particularly our pulse crops, they go into a situation where weed seed numbers are as low as possible, and we have some chance of growing an effective crop. But again, Weed Smart Big 6. Google that and have a good look at it, and you'll see a lot of really good information about the processes we're using to at least keep ahead of the weeds, because the weeds are trying to get ahead of us. We have to keep ahead of the weeds.
Okay. Thank you very much. I'm sorry for people who would like to ask further questions, but we have exceeded the time dedicated to the discussion. So we are reaching now the end of this webinar. I would like to thank you very much, Mr. Barry, for this rich presentation and also rich answers to the questions. I would like also to mention to everyone that, as usual, you will get a very short survey when leaving the webinar to get your assessment of this webinar series. Please fill it, it will be helpful. At the end of the questionnaire, you can request your attendance certificate for those who want it. I will give you the floor, Mr. Barry, and also Mr. Usama after. I will say that on behalf of the organizers, I would like to thank everyone who participated today, and also to thank Mr. Mohamed Boulala for his great contribution to prepare this webinar, and also for inviting Mr. Barry to have this rich webinar. I would like also to thank Mr. Usama Al-Gharras for his great contribution. Also, thanks to my colleagues Boutaina Abidou, Atman Batar, Dat Tirazi, Noordin Bahri, and Abdelaziz Yasri, and all the scientific committee of the INRA webinar series for their crucial contribution in the organization of this series. Mr. Barry, you would like to say something?
Yeah, I just noted, I haven't been looking at the at the participants. I see Dr. El Marid there. How Dr. El Marid and Aziz, it's great to see you too. And I apologise for not going through the participants. I'm sure there's some other people there.
It's a pleasure, Barry, to see you.
It always, I always love our conversations.
Please
Mohammed,
come back.
Yes, I'm hoping to reasonably shortly. All I was saying, what I'm going to say was that you have my email address. I am really happy to engage in any discussion with anybody at any time about these things. I love the interaction between the countries. I wish we could do a lot more of it, but I just encourage anybody who wants, just grab hold of my email address, send me something. I'll reply as soon as I can with as much information as I can provide. So I'm really happy to enter into any discussions at any time with anybody.
Okay, thank you very much. So we'll share your email address with colleagues who would like to ask further questions and to go further in details. Also, Mr. Barry kindly accepted to share the PDF of his presentation with you. So we will share it in a message separately, in a message tomorrow, maybe on the website of INRA or other tools for sharing information. So, Mr. Osama, would you like to say something, or Mr. Bourlala, maybe also Mr. Mourid, because Mr. Osama,
yeah, thank you, Mohammed. Yeah, thank you, Barry, my friend, and thank you also for accepting to participate to this webinar and your passion in responding all the questions. And yes, I think the Australian experience is and will be very useful for our 1 million hectares. We have similar environments as we saw, and yeah, we hope we keep contact with the colleagues from Australia in order they have really accumulative experience, and we need their experience, and we have to use it in our future 1 million hectare no-till 1 million. Thank you very much, Barry, for this. Thank you.
My pleasure.
Absolutely, yes. It will be very helpful for the roadmap led by the Agriculture Ministry in Morocco, because we are expecting to have the 1 million hectares of no-till system in the horizon of 2030. Okay, thank you very much, Mr. Mohammed.
Sorry, just on that note, I just, of course, I know there are opportunities for interchange of information, and I know Dr. El Marid has linked me with a person who is looking to bring some Moroccan farmers out here. I also have a project through a Rotary where I'm trying to bring some local farmers and researchers out to Australia for a short visit. So yeah, let's hope we can just make some of these interactions work really effectively.
Perfect. Thank you. Mr. Mourid, you want to say something?
Just thank you, Barry. It's a pleasure to see you. Thank you, everybody. Thank you, INRA organizers, for inviting me. I think it was an excellent seminar, exchange of experience. I would like just to ask Barry, before leaving, one of big concern to Moroccans now is the residue management. And there was a meeting last week, and I said, yes, our main objective is to retain as much as possible residue on the soil. But I believe, please, I might be wrong. We discussed this in international conservation agriculture conference in India many years ago. It should not be a constraint to move with the no-till and conservation agriculture system in Morocco right now. It should not be a blockage. It should not be a constraint not to do it. We should go, whatever the cost, to semi-direct, to conservation agriculture, and with time, in 5-10 years, we will improve. When we improve the agronomy, the crop rotation, diversification, and we will reach the objective of keeping as much as residue. But it should not be the constraint not to move to conservation agriculture. Please, can you help? What happened in Australia since the late 70s, early 80s? Did they were they concerned not to go to conservation agriculture without keeping as much as residue? Sorry,
No.
thank you. Because this is a big concern that many people raise, but I think in El Gharras, in our agenda, we think we should move, and we have done it. The benefits are there. Perhaps if we reach 70-80% of the benefits, is very good. But when we reach 100% or 80% residue, we will be there in the full concept of conservation agriculture. Thank you, Barry. Please come back. We're missing you.
So actually, it's a question.
I think,
Sorry.
you are right. You are very correct. So the residue part is almost the icing on the cake, and it comes from having very productive systems. So if you can, but the no-till part of it, and I know there's an issue in Morocco and in North Africa generally regarding perhaps the availability of some of the machines to do the job properly in terms of the correct machine to no-till. But if we can do the no-till bit, certainly do the right rotations and start getting crop diversity and the productive system that gives. And I always remember the comment made also by a good friend of Morocco, Dr. Alan Mayfield. His comment was, if you get the agronomy right, you can sow a crop with a blunt stick. Now, so basically, the sowing bit is let's stop ploughing. We know ploughing, deep ploughing in particular, but ploughing is not necessary. So let's get rid of that. No-till, yes, because we know we can establish crops successfully with no-till. Get the focus on the agronomy and the crop diversity, the rotations. And if you get productive systems, yes, the residue bit will follow.
Okay, thank you very much. Thanks again, Mr. Barry, for all this great contribution, really. So for the next webinar, we will have the summer break. So the next webinar is scheduled in mid-September. So wish to everybody a great and nice summer, and see you in 2 months. Bye-bye. Ciao.
Bye all. See you, Aziz. Good to see you there.
Bye. Thank you. Thank you all.
Bye.
Thank you, brother.
Bye.
Thank you, Barry.
Bye.
Bye-bye.
Thank you.
Bye.
Bye.